Hi, it's Wednesday morning. I thought I'd do a quick video here as a further attempt to simplify the materials that are being covered in Chapter 8 and 9 this week. I noticed that the discussion forums were thin, and I wondered if that was because the material is just confusing you. And I wouldn't be surprised if it is, because as I have said, this material is covered in course-long courses. It's very complicated stuff, and so if you don't have a background in statistics or probability and probability, or have taken a computer regression analysis course previously, I can see how this material would really throw you off and leave you kind of wondering what's going on. So I thought I'd try one quick video here to simplify and reassure you, okay? Simplify the material and thereby reassure you that parts of it are important for you to know and parts of it are not important for you to know, because you'll never, or you are unlikely to be called upon to actually do this sort of work, okay? So I want to take us back to this graph that's in Chapter 7, okay? And this is about this yellow area. How do you actually measure program impact? And the problem, and the graph here basically shows that over time, program participants, or people who got the intervention, ended up doing better on whatever variable it is that the intervention was trying to improve, okay? So there they go, okay? So that before they were down here, afterwards they were up here. But the problem comes in that there's an assumption that over time, the program participants probably would have gotten better on whatever it is they're trying to get better on. They would have gotten better by themselves. That's what this line shows. And so the real program impact is not all of the gains from before and after, but the gains that occurred only because they were in the program, this yellow area, okay? And so that's what you're trying to measure when you do an impact study, okay? Hopefully that worked well. Okay, but the problem is that estimating what the clients would have done, without the program is virtually impossible, right? And I'm going to read now from 267, Biased in Estimation of Program Effects. And it says, halfway down the page, because the actual outcome without intervention cannot be observed for the targets that do in fact receive the intervention, we have no ready means to determine when there is a kind of bias in the estimate of the program effect. In other words, you cannot estimate what they would have done if they didn't have the program, because you can't observe them not having the program, right? If they're in the program, you can't see what they would have done if they hadn't been in the program. So trying to estimate this bottom line here, is really, really hard. And so how do we do that? If in reality we cannot observe what they would have done without the intervention, how do we then approximate what they would have done, or guesstimate what they would have done without the intervention? And Chapter 8 talks about how random assignment of a control group and an intervention group is the best way of trying to do that. And if I read here a little bit further on 267, it says, note that the advantage of a randomized design is that though it may misestimate the outcome without intervention in any given instance, the randomization makes that happen only by chance, so that over and underestimation are equally likely and there is no systematic bias. Okay, what does that mean? That just means that, in any given case, any given person in the treatment group may do better or worse than someone else, but because you have a whole bunch of people in the program, the people who for some reason or another do better are going to be outweighed by the people who for one reason or another randomly do worse. It's sort of like the old coin toss, right? We know that there's like a 50% chance that the coin will end up heads or tails, but each time we do it, I got a tail that time. I went to one extreme, right? And I do it again, that's a head. I went to the other extreme. And so with each of those chances there, I had two extremes. I had people who did really, really well in the program, and I had somebody who did really, really sucky in the program. But if I keep flipping the coin, and I do it 100 times, I'll get to that median where 50% of the time it was heads and 50% of the time it was tails. And so that's what they mean by the randomization. There'll be chances on either sides, but if you have a randomized control group and a randomized intervention group, then the average of how they perform, when you take all those individual people, average out how they did, the difference in the average should be the impact of the program and the intervention that they received. Okay? But so that's chapter 8, talking about randomization. But what happens is that we can't always have a randomized division of people, of like people into the program who get the intervention and the people who didn't get the intervention, and comparing the results of the two. So what do we do in those cases? And this is where chapter 9 then talks about different ways of trying to estimate the program effect when you can't have the control group compared to the intervention group. And that's where this chart maybe comes in. Okay? In other words, within the control group or the program group, people do better or worse on the thing you're trying to improve, right? There's the bell curve, so to speak, right? And we have people who do better than the average. You have people who do worse than the average. And so using statistics and computers and all sorts of stuff, people start to say, well, how come this person did better than average, this person did worse than average? Is it because of other factors other than the program intervention? Let's see. Could some people do better or worse because of their gender, or because of their age, or their income, or their race, or their educational level? And so what you try to do is identify factors that have nothing to do with the program intervention that could explain why some people do better or worse on that element that you're trying to make improvements on. Okay? And so if you can explain away the differences between people who do better than average or people who do better or worse than average, then maybe you can explain the difference between those who are getting the program and those who didn't get the program. In other words, of all the differences between people who get the program and don't get the program, their achievement on a particular element can be explained by factors that have nothing to do with the program. Well, then the remaining difference then might be what's attributable to the program itself. Okay? And that's sort of in the middle of the chapter. This is on page 283. What I just said is basically what they try to say here at the top of 283 when they're talking about modeling the determinants of outcome. If the average outcome of the intervention group is better than the predicted from initial status being gender, age, income, race, education, or other variables, while that of the control group is not, right? The average outcome of the intervention group is better than that of the control group, then the difference is interpreted as the program effect. An alternate phrasing is that the analysis tries to establish whether or not receiving the intervention itself is itself a significant predictor of outcome when the predictive relationship of the control variables, those other characteristics that they come into the program with, has already been taken into account. Okay? And then they talk at the end of that chapter about reflective controls, and that's essentially what most of us do when we do impact studies, right? We take a pre-test, we take a post-test, and we say, well, that's good enough. And we don't really try to measure how they would have progressed without the intervention, okay? Because again, trying to estimate this improvement that would have happened anyway is really difficult to do, okay? And they also talk there about time series data, and that's essentially when you measure things over time. This is what's happening generally, and then an event happens. And then you look at that same indicator over time after that event, and you see if that event causes any difference. Is there a jump or a discontinuation in the data at the time of the event, or maybe a little thereafter? And then you make the assumption, or you make the guess, that the change that happened before, the change that occurred after a certain event in time happened is attributable to that event. Okay? All right. 12 minutes, I think that's enough. What's really important then is to just know the concept that you can attributable everything, that all the improvement in a particular program group, or treatment group rather, to the program itself, because there's inevitably some probably good or bad things happening that would have occurred even without the program impact. Okay? As I say, this is pretty advanced stuff, and you're not likely to be called upon to understand how it all works in its details. But what is important is in the Harlem Children's Zone case study, the impact of trying to get impact analysis on operations and on how organizations kind of work in their culture, and we'll talk about that in another video and in the discussion forums.